Good morning and good evening if you are in the United States today. It's a pleasure to have you with us on this beautiful Wednesday morning in Japan and Tuesday evening in the United States. Before I introduce our guest speaker, I would like to say that today we're going to talk about a topic that is a very first time for us. We have never ever discussed the topic of Japanese aviation production and the industry here. And I'm very glad to say that we are able to do this thanks to our guest speaker today, James Hoadley. As you probably know him from LinkedIn because he's very active there. And I would like to say that I will let him introduce himself. But before that, just let me say that James is a very well-known LinkedIn member, of course, for those who are not in the United States and who are not in Georgia. So he is based in Georgia, and he is an associate director of Georgia Tech Center for International Business Education and Research. And that's the Georgia Institute of Technology and Georgia Tech's Schiller College of Business. So, James, thank you so very much for making time to be on the podcast, and welcome.
Well, thank you, Maya. It's great to be here. So a little bit more about myself. Why am I talking about aviation? Why am I talking about Japan in that particular? I have published some stuff on the aviation industry, but it's all been focused. It's a name that you'll hear coming up again. It's about the Chinese that I've focused particularly on them. But I haven't really had an opportunity to publish in peer-reviewed journals on the issue of the Japanese aviation industry. And it's something that has always fascinated me as we watch China take its first fledgling steps into making its own commercial aircraft industry. The question that I always ask is, why not Japan? And Japan has had a number of attempts, a few, and we'll talk about those, I'm sure, before the conversation is over, about which ones it had, which ones worked, which ones didn't. But it's a topic that is of great interest to me and one that I've been following for a long time. So I'm happy to be here and to share my limited expertise with you.
Thank you so very much for that. And yes, this is a topic that has been fascinating me for quite a while. But me not being in the engineering field or the educational, let's say, industry, I have never felt knowledgeable enough to talk about it. Still, thanks to you, this time I did a little bit of research, which is probably not enough at all, but I hope that today we're going to we will be able to actually provide some different perspectives on this, because Japan has it has a long history, let's say, of building aircraft, but also parts for the aircrafts, because some of the projects have been unsuccessful and others have been successful. But one would wonder really what kept Japan from building its own aircraft that has been successful, right? Because now we know that Honda, at the moment, they build those small jets, the business jets, and they are doing pretty well. But anything bigger than that has not been a success, has not resulted in anything really sizable. And of course, this industry in Japan it has history, its own history here. And when we talk about history and when we talk about success, of course, we know that we cannot divorce these two things, from the background at the time, right? And the environment of the time, because most of the time, if you want to be successful in business, of course, you need to know what your environment and what the landscape is in the country. And maybe we can start from there. I don't, yes, I hope that it's okay with you. But if you prefer a different starting point, we can start from there as well.
Okay. Sure. I mean, I'm happy to talk about Honda a little bit, even though that's not in my notes, but I am familiar with them because their primary manufacturing facility, at least in North America, is in North Carolina, which is not too far away from where I am. And we have, through the organization that I'm involved with, the Japan American Society of Georgia, we have had talks by executives from Honda Jet. That's a very interesting case. Honda, of course, is always known. When Honda Soichiro created the company, he called it Honda Giken. In America, we think of it as Honda Motors, but Giken is a much broader term that means basically kind of precision engineering.
Right.
If I could translate it roughly, and I'm sure people in the background are just going, "Oh, he's getting it wrong." But it's kind of the idea of Honda Giken. It's more technology. So they have always shown a desire to go into spaces that may not have seemed to be in their main stream, whether it's making the Asimo, which was a fantastic,
Mhm.
unfortunate technological dead end, but it was a beautiful, fantastic, and an amazing one. But we don't have Asimos running around our houses right now.
Yeah.
But so with the Honda Jet, the idea there was to look at a space that was very a niche that they felt was not being adequately served, which is in places where there's not a good high-speed rail infrastructure like North America, where there's a lot of distance between spaces, again, like most of North America and South America as well. Um, how do executives get from space to space when they have facilities located all around? And that's where they have really found their niche. They've developed their own engines, which is a remarkable thing. And they, of course, they developed their own airframes as well, and they have that unique engines mounted on the top of the wing configuration, which nobody else has that. And it provides a number of technological advantages, which I think kind of ties into the overall theme that I was trying to get to, which is that Japan clearly has a successful space program. It has high-speed rail. It has many other high-tech engineering industries that do very well. Why has it never been able to crack the nut of commercial aviation? And I have a number of ideas, but I think that rather than me just sitting here and dictating them, it would be great for us to talk those out.
Yes, because we know that after the Second World War, of course, Japan was not really allowed, if I can say that, to develop
Mhm.
any industries that might have dual use, right? At the
Right.
time. And of course, this is changing nowadays, but I believe
Mhm.
that at that time, maybe Japan just lost the chance of starting the development of jets, right? Civil aviation jets. But I may be mistaken, right?
Well,
Because
I think that one of the commercial aviation successes that Japan had building the entire aircraft was
Mhm.
the YS-11,
Oh,
which was released late 60s, early 70s. And it was fairly successful for what it was trying to do, but it was a turboprop. It was not a jet-powered aircraft. My father flew in them quite a bit in his job as an engineer, flying around from small location to small location in the United States.
mhm.
Uh, and actually, even today, there are locations that Japan could theoretically, if they wanted to build a commercial aviation industry, that might actually be a good place to start, is replacing it's not sexy, you know, big jets are sexy. Small turboprops that fly to islands or something like that. You know, if you're going to Hachijojima or something like that, and you're going to be on a a, probably a turboprop aircraft, those airframes, by and large, are quite old, and getting older by the day, and they need to be replaced. That would be kind of an undefended hill that Japan, theoretically, a Japanese manufacturer could get into, but so far there doesn't seem to be any push to do that.
Right. Yeah, it looks like there is no push at the moment, and I wonder whether there will be any in the future because currently, I have to say, currently Japan is developing, let's say, a fighter jet with Italy and then Britain.
Mhm.
But of course, fighter jets are very, very different from civil aviation
Yeah.
airplanes. And probably the technologies used in the two well, the two aircraft are very different. So I believe that at the end of the day, probably Japan and the institutions, let's say Kasumi Gaseki, they will have to get over the disappointment of the failure of the Mitsubishi regional jet first, and maybe from there also try to develop or purchase, I believe, some technology that will help them develop their own jet. But
Well, I think that the fighter jet that they are developing, the nice thing about fighter jets, the bad thing is that they are much more demanding in terms of engineering because they have to perform in a much wider range of stresses, and they have to carry ordnance and things like that, which of course commercial planes do not have to do, and hopefully they don't. Uh, but the big issue, which will, when we get more into the MRJ talk, it will come up again, is the certifications. Military aircraft don't have to have a super complex certification process. It just has to be proved, does it work doing what you want it to do, or does it not do it? Commercial aviation not only has to meet a very complex certification process in both North America and with the FAA and in Europe with its certifying body, but it's a system, it's a certification process that's been designed to help the incumbents. And
yeah,
and then in addition to that, you also have to deal with labor issues as well. No unions for military officers, but particularly in North America, all of the pilots, at least all the ones who fly on the major airlines, are all members of the pilots union. And the union has something that we'll talk about in a couple of seconds. It has scope clauses, which is really what sank the MRJ. So.
I see. Yes, and also I hear from people who worked on the project or basically supported the project of MRJ when it started, is that, well, MRJ could not pass those tests, the safety tests, because there were, what do they call them? Let me see my notes here, because, yes, this is the safety, fail-safe safely test, right? So, and basically, they say people here who worked in that area, they say that Japan did not have the necessary technology to pass the test because at that point of time, right?
It's interesting that they're saying that. I'm sure that they are saying that, and that's very different from what my research has shown.
Okay.
Um, I'm I'm processing why they're saying that. That's very interesting that they're saying, because I think Japan has the technology to meet the safety requirements. I don't think they have necessarily the internal expertise. You
Mm-hmm.
know, Boeing and Airbus have large offices that are already designed, that they are set on the certification process. I don't want to say that safety requirements are not necessary. They certainly are, but
Mm-hmm.
there's a level of government regulation that can go in. There's what actually protects people's safety, and there's a lot of that out there.
Right.
But there are also restrictions in place from the 1960s when the YS-11 was being designed and put in. Safety at that point was really concerned with what can you do to prevent known threats, known accidents that we've had thus far, to prevent those from happening. Now, from what people have told me, the regulations are not concerned about that. They're concerned about, not only do you do that, but you also have to be able to predict any other outlying unknown safety failure. You have to predict, and you have to compensate. You have to show how you're going to compensate for that too. That's a lot more difficult.
Yeah.
And the people who are deciding the standards by which the aircraft are judged there are government officials,
Yes.
there are some academics, but there are also representatives from Boeing and Airbus who are on those panels. And for an outsider to get in, they would have to skirt the regulations that are put in place with the consultation of their opponents, of their potential competitors.
Right.
So yeah, they're not going to make that easy for anyone.
Yeah. The incumbents are always probably the hardest to deal with. So,
Absolutely, absolutely. And in the U.S., Boeing now is a huge behemoth now that it's swallowed up or was swallowed by, depending on which interpretation you have, McDonnell Douglas.
mhm.
Um, it is really the only manufacturer making passenger aircraft in America. On an unrelated to Japan note, but on a broader note in the aviation industry, this is also one of the things that seems to be holding back. There are attempts in America to build new supersonic aircraft, supersonic
Mhm.
transport jets, and those are experiencing similar problems in that they have to meet safety requirements that are being put in place by companies that would suffer if they were successful.
Right. And that's not just the French, right?
No, actually, for super, there's the one thing that helps them is that there's nobody else who's trying to make a supersonic. There are small companies that are trying to make supersonic aircraft, but the major manufacturers are not trying to compete in that space. So that, from that particular standpoint, is somewhat helpful in that they're not seen as a threat yet. But
Right.
if they get to a significant point, size, you have to imagine that there's going to be some response from Boeing and possibly from Airbus.
Right. Yes, I also wonder though, because we're talking about Boeing and Airbus, and Boeing as an American company, it's become really like a behemoth, right, in the industry. But the thing is also, we know that every project, especially in the aviation industry, when you produce aircraft, it requires a lot of upfront investment. And that investment is huge. And well, that in itself is a huge entry barrier to into the industry, right? So,
Yes.
and as you say, there are some smaller companies, for example, in the United States, that are probably trying to develop the supersonic civil aviation airplanes, but they are not allowed. And I gather from what you just said that for them, the upfront investment is not such a big issue. It's much less so than, well, those companies like Boeing, for example, or Airbus that are not willing to move into that direction themselves.
Right. And another thing that is a barrier to entry is network effects.
Mm-hmm.
Um, because there are lots of trained technicians who work on Boeing aircraft, a lot of trained technicians who work on Airbus aircraft, and who work on the engines that are involved, which is the most complicated piece of machinery on the aircraft. There are not, just to use the example of the P-1 coastal patrol submarine, anti-submarine aircraft that was developed and built completely from scratch in Japan. Um, that hasn't sold. It's a military aircraft. It has not sold outside of Japan, not because of restrictions on the export of military technology, because it is pretty clearly defensive,
Right.
but because, and it's actually better in most respects than its competitor, which is the American P-8 Poseidon, which is developed from the 737 next generation, just one generation older than this,
Mm-hmm.
than the current one. It's older than the Max. Um, it's developed off of that. Well, that's retrofitting an old airframe that was optimized for carrying passengers at a relatively high rate of speed at 35,000 feet from point A to point B. The Japanese, the P-1, on the other hand, was designed to fly low and slow and to loiter, and it has 4 engines instead of 2, which is really important if you need redundancy, which if you're going to be flying in all kinds of weather and maybe people are going to be shooting at you, you might want to have an extra engine in case they hit one of them.
Okay.
But it has not sold very well outside of Japan. They've had a number of abortive talks to sell it to New Zealand. New Zealand decided on the P8. I'm trying to remember who else they've talked to, but they've talked to other countries as well. And they pretty much all of them have decided on the P8 Poseidon, even though it's in many ways an inferior aircraft for the purpose that it has. There's an argument that because the P8 has a magnetic anomaly detector boom on the back, because the P8 is designed to replace the P3 Orion, which was an American developed from a turboprop commercial plane and served many years, but it was the P3 Orion had a large magnetic anomaly detector on the back, which they use to detect submarines when they're flying over the surface. It can pick up the magnetic differences. The P8 does not have that.
All right.
Doesn't really even have space to add one. The argument that is made is that you don't usually find submarines that way anymore. Modern submarines that are built by the Russians and to some degree the Chinese are made out of titanium or some other material that is non-magnetic, so it's not going to detect it either. For the case of Japan, they're not really looking for as much for the top of the line Russian or Chinese submarines. They're looking for North Korean submarines, and those a magnetic anomaly detector might find them.
Right.
And of course, the use of a magnetic anomaly detector, it also is dual purpose. If a ship sinks and you don't know where it sank, you can go along with it's like a big metal detector flying over parts of the ocean, and you can detect where it sank if you know where to look. The P8 can't do any of that. It's designed for super cruise at high, super cruise, I'm sorry, that's a terminology that is used for, I used the wrong term there. It's designed to cruise at 35,000 feet at a high rate of speed, and the P1, of course, is designed to loiter at low altitudes over the ocean for a long period of time. It's got giant windows. Why do pilots in a passenger jet need giant windows? They don't. But if you're looking for, let's say, North Korean fishing vessels, that could be very helpful. You can look out the front. It's when you see them side by side, the P8 and the P1, it almost seems like they're not the same scale.
Right.
Like if you had 2 toys of them and you put them and they were actually the same scale and you put them next to each other, it wouldn't look like it. The P1 just looks much larger, much more robust. And Kawasaki, of course, developed it. And there was a statement that Kawasaki was considering making a 2-engine passenger model. They've proven, of course, that the plane works, that it works very well. But all of the things that it's designed for are the opposite of the commercial aircraft mission. And that's why it really hasn't been successful, why it wasn't successful. It doesn't translate well. So.
Right. Yeah, no, that's a very insightful observation, because I never thought about that actually. My focus has mostly been on commercial aircraft, but of course Japan has a lot of technological know-how when it comes to building aircraft that is used, as you say, can be used for dual purposes, right? But at the same time, because I also do cross-cultural consulting for businesses and everything, and the most often, the reason that I hear most often about industries that have failed in Japan, and basically producing commercially viable aircraft here has not been very successful. people say, yeah, Japan is such a risk-averse country, and it makes a lot of sense that they failed in that. And I tend to disagree with this, especially when it comes to the aviation industry, because many people believe that Japan is risk-averse, but I would say that the Japanese in general, basically, I wouldn't frame it as risk-averse, they're just process-oriented.
Mm.
And when your process requires time to get everybody on board and to make everything works before you launch, launch the machine or the product or everything, then of course, naturally, you don't want to go into sudden changes, right? So, but I would love to hear also your opinion on this.
Well, as a person who flies with some frequency, I don't know that I would want to fly in an aircraft that was built by people who were not risk averse.
Okay, that's a good way to put
It's,
it. I love it. Yes.
it sounds like an old Bob Newhart skit. You know, take a chance on Mrs. Grace L. Ferguson's Airline and Storm Door Company. Um, Classic.
Right.
Yeah, you don't want to be in a commercial aircraft. You don't want to be on a plane where they said, that's good enough. We'll take a chance with that.
Right.
So I don't think that that's necessarily a barrier. I think the real challenge is that Japan is really good in particular sectors. I don't know if I mentioned or not, but they make about a third of the content that goes in the 787 Dreamliner. It's manufactured mostly by Mitsubishi, but there are other manufacturers, Kawasaki's in there as well. And they make important parts of the plane. They make the wings. They make large portions of the fuselage. They make the really difficult stuff to manufacture. And they build it in a way that is consistent with Japanese sensibilities, in that they build it consistently, so the parts always fit. They build it to a high standard of quality, so that everything is always the way that it's supposed to be. The problems that they have had with the 787, I have not heard a whole lot of problems with the manufacturing coming out of Japan. The problem has been mostly growing pains coming out of my adopted home state of South Carolina, where they moved all of the production of the 787 to North Charleston, South Carolina. And they're having a bit of a challenge getting the quality control up to the level that they need it to be. But that hasn't been a fault of the Japanese manufacturers. I think that if planes were manufactured in Japan, you would see a lot of manufacturing know-how that would go in that would make them very consistent in terms of quality, and you would not have probably, it's not perfect, and I am showing a bit of my Japanophilia here, but I don't think that you would have doors popping off in mid-flight
Right.
with a Japanese manufactured plane. There are instances where Japanese manufacturing has failed as well, but it tends not to be things that are manufactured in bulk. It tends to be things that are one-off.
Yeah.
And to some degree, that's a problem with all of Japan, both military and commercial. This is a problem with Japan's manufacturing in these industries, is it tends to make a lot of one-off products. The MRJ, to tie back into what we were talking about, the Mitsubishi, the SpaceJet,
Yeah.
it was really kind of a one-off thing. It wasn't designed, they didn't have the commitment to continue it. I don't think they had the financial ability to continue it. I don't think they had the support from the government to continue to take losses initially, which they would just have to do in order to break into the space. Now, to be clear, the MRJ was not competing really with definitely not a Boeing product, and arguably not an Airbus product, although the A220 might be kind of in the same space, but not really. And the thing really that I think, if there were always a number of factors, but I think the number one thing that killed the MRJ was scope clauses. And most people don't even know what a scope clause is.
Right. Yeah.
In the American aviation structure, which would be the key market that any regional jet would need to get into, to be successful for the most part, you would have to compete, you'd have to comply with scope clauses, which are not an engineering problem, they're a labor problem. US pilot airlines limit how much major airlines, if they're using feeder airlines, they limit how big the feeder airplanes can be. Because the feeder airlines that supply them, those pilots actually get paid fairly little. Like some of them have to take other jobs so that they can live because they're getting paid so little on flying their commuter jet, but they don't fly out of big airports like O'Hare or LAX or Atlanta. I have to mention Atlanta because we're right here.
Right.
They're flying out of Lexington, Kentucky, or Butte, Montana, or someplace like that. Now you wouldn't get a huge number of seats from Butte, Montana, for example. But if a company wanted to break the pilots' union or reduce their power, you just keep putting larger and larger planes on your feeder routes, and those pilots are not union, so you don't have to pay them anywhere near as much. Now, what the Japanese assumed was that scope clauses had been adjusted in the past, and they assumed that it was simply something that could be negotiated away. That never actually happened. The airlines decided it was better that they were just going to live with the scope clauses as they were and not provoke a long-term labor fight with the pilot unions, versus getting larger aircraft, better aircraft. The MRJ was better than anything that it was competing against at the time in terms of efficiency, in terms of quality of passenger experience, but it was too large. It was over the maximum seat limit of 76 for both versions, and the smaller version, which went under the seat limit, it was too heavy because they also have maximum takeoff weight limits as well.
Oh, I see.
And so they had two planes that were fantastic, but they didn't meet scope clauses, and they were hoping that scope clauses would be adjusted, and they weren't. And that's really the biggest reason why nobody went with the MRJ, because the Pratt & Whitney engine that was powering the MRJ, that was very familiar. It's installed on a lot of corporate jets. So there certainly was a base of maintenance workers who were familiar with working on that particular engine. That wasn't a problem. A little bit more of a problem in terms of other maintenance besides the engine, but of course, as we said, the engine is the biggest component and the most complex one, the most finicky one. The really confusing thing for me is that when Bombardier, which did compete in this space, when Bombardier, the Canadian company, basically imploded, which is a whole different podcast.
Right. Yes. We need to do that too.
Okay. I'll need some time to do some research on that.
Yeah.
But so that I can sound smart-ish. But when Bombardier's aviation division failed, it had a huge market share.
Right.
The CRJ, the former Canada Air regional jet, had a huge market share, and Mitsubishi bought all of that, but they didn't buy, because it had already been sold off, what became the Airbus A220.
Oh, okay. So is that you're talking about the patent there, or is it the technological patent or the design of?
What Airbus got was it got the rights to produce the aircraft, so it got all the designs, it got all of the machinery, it got the factory in Quebec.
I see.
Where they build them. So it got all of that. The only part that was left was the part that was servicing the CRJ aircraft, and these were 30-year-old aircraft in design. They had served their purpose. I've ridden in them. They're fine. The ceiling's awfully low. I have to duck. And that's actually part of the problem, is that the ceiling is too low. But it doesn't run up against scope clauses. It's perfectly fine with those. But it was an airframe that had reached the end of its economic life.
Right.
To
Okay.
make it usable, Mitsubishi would have needed to put new engines on it, new avionics, new wings. At that point, it's no longer a CRJ anymore. It's a whole new airplane, and you've already got the MRJ, which was designed from the ground up that way. But so Mitsubishi, even to today, still has the business on support for CRJs, which are still flying out there today, but
Mm-hmm.
they're getting replaced, and they're mostly getting replaced with Embraer aircraft. So the Brazilians, that's who they would have been competing mostly against. So in that small regional jet space right now, the only competitor that you have left that's really dealing with regional jets is Embraer, which is a whole story unto itself because it's having problems as well. Which you would be like, well, if have a monopoly on the market, why would you have a problem? But
Indeed. Yeah.
it's that's a complicated story unto itself that is not necessarily related to Japan, but a fascinating story as well. So really, the purchase, I don't understand it. I sort of understand it, why Mitsubishi bought what was left of
Mm-hmm.
Bombardier, but it didn't really do Mitsubishi any real good.
Right.
Um, it certainly didn't help the MRJ by creating a new pipeline of they can say, hey, we have the new hotness, all that sort of stuff.
Mm-hmm.
And just as a counterpoint of how important, once you establish a dominance in a particular space, a lot of the problems that have been happening with the 737 Max, with the TCAS system, the system that was designed to take over the aircraft,
Mm-hmm.
because that's a result of airlines wanting to maintain continuity.
Okay.
Boeing could have designed a new aircraft from scratch, but then pilots would have had to be completely trained from scratch on this new
Mm-hmm.
aircraft. So instead, what they've been doing, and what they've been trying to do for a very long time, is to improve the performance of an existing design that literally dates from the 1950s. It was first
Mm-hmm.
drawn up in the 1950s by putting larger and larger engines on it.
Right.
The problem that faces the 737 is that it's very short to the ground, so it doesn't have a whole lot of clearance. For the
Oh.
original jets, the turbojets that were on the 737, that wasn't really a problem because they were very long and thin, as jet engines at the time were. But as we've gone on, we're no longer in the turbojet age, we're in the turbofan age. Specifically,
Mm.
we're in the high bypass turbofan age. And a
Right.
high bypass turbofan, without getting too much in the weeds on that, is basically it's a ducted fan that it has a jet engine inside of it that powers the fan.
All right.
But most of the air that's going through is not going through the jet engine itself. It's going through the fans on the outside.
Oh, wow. Okay.
That can produce a very highly efficient source of propulsion. And every plane today, commercial successful one, uses a turbo fan. Um, and actually, the MRJ was fitted for a geared turbofan, which if people want to know about geared turbofans, they're really cool, but they're also really, really nerdy.
They're nerdy. Okay.
Yes, so I'm not going to go into a whole lot of details on that, but it actually allowed even better performance than a standard turbofan.
Mm-hmm.
The problem from the 737 standpoint is when you stick larger and larger turbofans on it, the engines start hitting the ground when the plane lands.
Right.
That's why in the 737 next generation that the P8 Poseidon is developed from, if you look at the engine nacelles, they're not round, they're like
Mm-hmm.
squished on the bottom.
Right.
And that's because the solution at that time to make a larger turbofan was we have to fit the fan in, but we're going to take some of the equipment and we're going to move it up on the side so that you have clearance on the ground.
Right.
And then the problem from the Max's standpoint is the engines that they installed, they're extremely efficient, but they would not offer enough ground clearance. And so that's no good because you can't have the plane scraping the runway every time that it lands. The solution that Boeing implemented was to move the engine forward and up. And that changes where the center of thrust is in the airplane versus the center of balance.
Okay.
And it created a plane that naturally wanted to pitch up. And in order to keep pilots from having to extensively retrain all of the thousands of pilots out there who are qualified on the 737NG, to keep them from having to go through a very extensive retraining process, they said, let's invent a system that will counteract that automatically so they can't outfly the airplane.
Right.
And let's make that system kick on based on airspeed, which is only detected through a single detector.
Okay.
And let's, to avoid confusing the pilots, let's not tell them that we've installed it. And so they can get requalified to fly the 737 MAX on a 1-hour course on an iPad. And yeah, that'll all work fine. It's not a single thing that was done. It's a whole series of decisions that were made. And the problem that both the Ethiopian and the Indonesian jets faced was those airspeed detectors became clogged. The system that was designed to prevent the plane from stalling started pushing the nose down automatically. And the pilots could not get control, could not override the system because they didn't know it was there.
Right.
So anyway, that's very far afield from talking about Japanese commercial aviation. Sorry.
No, that's okay, but it's also interesting because, well, of course, Japanese producers, they produce engines and wings and parts for Boeing as well. So, and of course, they probably have known that. But my question before we move back to Japan, is that, so at the end of the day, I wonder, of course, you mentioned that the designers and engineers of of the airplanes, they wanted to ensure continuity, right? And instead of creating a new design, a new airplane from scratch, they just decided to do this and to do that, so that the pilots will not have to be retrained. Of course, training a pilot is a cost for every company, right? But at the end of the day, I wonder which of these costs was bigger, because retraining the pilots is a cost, and then going through all those systems, creating them, implementing, putting them on the airplane is also a cost, right? So of course I think that we can just only guess at the moment.
Well,
But
the classic example doesn't relate to Japan at all, but it was the Ford Pinto. Where they did very famously the calculation, the way that they had designed it, the car would catch, the cabin would be sprayed with flaming gasoline if it was ever struck from behind, because of the way that it was designed. And they did a calculation of how much they were going to have to pay for compensation for people killed because of this design versus how much they would have to pay to re-engineer the line. And they decided that it was easier to let people die than to re-engineer the line. Of course, that turned out to be very, very wrong because their decision-making process came out in court after people were killed as a result of this design. And I think from the standpoint of Boeing, that's also an issue as well. But all of these things go to well, maybe not the Pinto so much, but definitely Why were they so fixated on continuing the 737 design after it had clearly reached the end of its life and it needed to be replaced with something else? Why did they do that? And the answer was there's so many 737 pilots out
Right.
there, and they don't feel that they're going to be competitive if they have to make a totally new plane that a whole new set of pilots have to
Right.
train on. And that, tying it back into the MRJ,
Yes.
was a barrier to the MRJ because it was not a continuation of Bombardier. It was not I don't even know if you could do that, but it was not a copy of an Embraer design. So they were, in addition to having to get all new maintenance people and all of the things that go along with that, they would also have to get a whole new set of pilots. And that served as a disincentive it's one of the many disincentives for airlines to accept the MRJ. It was a wonderful plane. Everyone who saw it while it still existed, the three examples, which are now all have been recycled into something else, sadly. It earned high praise and it deserved the high praise, but it was a perfectly designed, from the standpoint of an engineer, aircraft that didn't deal with the political realities on the ground, the political
Right.
and labor politics as well. So.
Right. Yes. And could you please talk a little bit about the political realities on the ground there, just for some background?
Sure. Well, I mean, if we're talking about scope clauses in particular, that's kind of a labor politics kind of
Right.
thing.
Yeah.
So I've already kind of talked a little bit about regional
Yes.
gaps and the restriction on those, and the maximum takeoff weight and the maximum number of seats. And the MRJ, the way that it was designed, was not compliant with those scope clauses.
Mm-hmm. Yeah.
Both of them, one was too heavy and had too many seats. And they felt that the economics of it would make that by offering a better product in isolation, that which it clearly was, that would surpass every other demand. And in
Mm,
the end, they learned a very hard lesson, which was that labor politics always wins out.
always. Right.
Um, Particularly with well-organized unions,
Mm-hmm.
as the American Pilots Union is. Airlines it wasn't enough of an advantage in terms of quality of passenger experience and fuel savings and all this, it had all of those things,
Right.
but it wasn't to them. They looked at that and said, "Is that worth provoking a a knife fight with our pilots unions?" And they said, "No, we're not gonna take that risk."
Right.
And so that's really what killed the MRJ.
Yeah. So because when you mentioned political, let's say, background, I always think about how it was here in Japan back then. And I do believe that the government, at the end of the day, well, at some point they decided that they were not going to support the project, right? And once again, it's politics, because when the government decides that they cannot, what's that, invest into the project, or let's say subsidize the project, then inevitably it goes downhill, because it's something that requires billions and billions of investment.
Well, a different comparison when you start talking about politics, that I think is actually very germane to why the MRJ failed and why another aircraft. I don't know that I would go all out and say it has succeeded, but it's one that it's the one that I'm published on and such. So I do like this aircraft quite a lot, and that's the Chinese Comac C919.
Right.
That is designed in a completely different environment.
Mm-hmm.
The Chinese government is backing the development of the C919. So number one, you've got the full backing of Beijing, so it can
Right.
continue to take losses for as long as it needs until it
Mm-hmm.
can get until they are capacity building. They are building the ability to have a commercial aircraft industry because they've looked in the skies. They look on the train tracks, and for the long time they were like, our high-speed rail is all built by the Europeans and the Japanese and the Koreans and the Canadians, and so they domesticized all of their high-speed rail. Well, then they looked to the sky and said, why is the sky filled with American and European planes?
Mm-hmm.
So China has a large base of potential
Right.
flyers. So
Mm-hmm.
it's a large market. It's a domestic, so it's very easy for it to certify itself to operate within its own space. And there's been very limited usage of COMAC aircrafts. There's the C919, there's the C909, which used to be the ARJ21, but they are renaming it for harmony and all that kind of stuff. That's the ARJ21 or the C909 was the only one that I know that has flown outside of China, and it only flew in Vietnam and possibly Indonesia.
Mm-hmm.
And while I enjoy particularly Indonesia, but I haven't been to Vietnam yet, but both of those are great countries. I hope that nobody gets upset when I say that the internal certifying structure to fly in Vietnam and Indonesia is probably less than it is in the European Union.
Right.
So, so meeting the certification in those places was not as big a deal. For the most part, they've been competing domestically, and they're going to continue to be domestic
Mm-hmm.
for a significant period of time. Also, if you look at the COMAC C919, another interesting thing. Now, this didn't affect the MRJ, but it did affect the P1, not commercial. I realize I'm mixing my metaphors here. The C919, if in fact I've used this in class, you can have like a map of, I have the 787 on one side and I have the COMAC C919 on the other, and I have all of the major components of the aircraft highlighted, who is the manufacturer and where is that country that the manufacturer is located. And in reality, I realized that the C919 is a narrow body and the 787 is a wide body, so it's not a full even
Right.
comparison. But the point I'm trying to get to is you look at the Boeing plane, and it's got parts manufactured in like 7 or 8 different countries. Significant percent of it is in Japan. A large percentage of it is built in Italy, and it's all flown and assembled in North Charleston, South Carolina. And then you look at the COMAC C919. Almost all of it is the main components, the engines, the avionics, the brakes, all of it is from American suppliers.
How interesting.
In fact, they're using a variation of the same engine that is on both the 737 Max and the new A320 series.
Mm-hmm.
It's
Right.
um, so it's not really, they're just building the airframe and then putting all the parts on it together. It's a very clear long-term strategic
Yeah.
positioning by the Chinese government, who doesn't have it, because of a lot of things about China, which you may not want to get into, but Beijing can operate in these ways
Yeah.
because they don't necessarily have to be responsive to shareholders. They certainly don't have to be
Indeed.
responsive to voters. Um, and Japanese companies like Mitsubishi have to be responsive to their shareholders to some degree, and they have to be and the Japanese government has to be responsive to voters.
Mm-hmm.
Um, and then
Yeah.
we have a snap election coming up next month.
Yes.
So
Yeah. And with everything you just said, do you think that well, the Japanese commercial aircraft industry, let's say, does it have a future? Or do you think that the future of this industry is basically producing spare parts and components for American and other airlines?
I
What
I
is?
don't I don't see those as opposites. I
Mm-hmm.
see them as different ways to approach it. I think that Japan has an aerospace industry. It is very successful in a limited sense, producing for its own use. The F2 is a great example. Great aircraft. They built a ridiculously low number of them.
Right.
Um, When the 3/11/11 tsunami hit, it took out a significant percentage of all the F2s that existed in the world because the tsunami swept over the
Mm,
base. Um, but they definitely have the ability to make. It's not a shortage of engineering. It's a combination of institutions, certification, and risk absorption.
mm-hmm.
A good quote that I had written down, I don't know who said it. Airplanes are not products, they are promises that last 30 years.
Right.
For a brand new company like Mitsubishi or Kawasaki or Shin Meiwa to, to do that, the companies have been around certainly that long and they should be around longer than that. But this concept of making this level of commitment to clients over the long term is not something that they seem to be have the ability to do on their own, and the Japanese government doesn't seem to be showing a specific desire to support that.
Mm.
um, I don't know that the Japanese government is in a financial position right now that it can do that.
That's a big consideration too. Yes.
Now that said, I think that in the spaces where it competes, I think Japan does quite well. It's had a number of mistakes in launching spacecraft. That happens. That's unfortunate. They'll come back from that. Um, People get obsessed with SpaceX right now, in particular in America, and its degree of success, but they forget how much SpaceX failed before it
Yeah.
got to this level of success. Um, and they're just different for a
They are
lot of reasons.
right.
But Japan is one of the few countries in the world that has its own space industry. Um, and that's an extension of aeronautical engineering. They make a lot of the critical parts that go into a lot of the aircraft that are out there. They may not be building the engines. IHI may not be a major global. The engine that they made for the P1 is a fantastic engine.
Hmm.
Nobody else uses it.
Right. That's
And if you have a better design and nobody uses it, how are you going to get them to start using it?
indeed.
So I think that's really the barrier for Japan, um, long term. And I think that Japan is happy to carve out the niche that it is carving out. But I don't think the MRJ was an interesting attempt.
Hmm.
And it was a beautiful airplane. If you look at pictures of it, it was beautiful. It was really nice to look at. Very sharp, very distinctive. It looked like a plane. I was like, man, I'd love to get on one of those. That would be cool. Um, and by everyone who flew on the demonstrator models, it handled well. It got great fuel economy. The pilot load was reduced. Everything that you want an airplane to be.
Right.
It was never a problem of engineering. It was a problem of how do you overcome existing systems in place,
Hmm.
and how do you get people to give up what they already have in place to try something new?
Right.
And people will stick with stuff that is suboptimal for a very long period of time because of things like confirmation bias and recency bias and all that kind of stuff. They're like, well, I'm committed to that sunk cost fallacy. That's an economics term. It's basically referring to a different element of the same thing. People don't like to change. And for Japan to be successful, I think the only way that they could is if they go into a space that needs aircraft and that is not being dealt with, which is nobody wants to deal with these small, um, turboprop puddle jumpers that have maybe 12 seats on them or something like that. That is serving a vital purpose.
Hmm.
The de Havilland Twin Otter, I actually have a colleague who sometimes is in his office down the street, but down the hall. But he was working to with a company, a startup company, to create a replacement for the de Havilland Twin Otter that was made from parts in China and assembled in Indonesia.
Mm-hmm.
Um, I don't know how that's going for him, but he certainly feels that there's a future in this space, and I think he's probably right. And nobody is addressing that right now.
Yeah. The one thing though, I also we're at the 1 hour mark, but I just cannot help but mention that, as you say, Japan, if Japan finds its niche, then definitely it will go there and do very well. But I also find something else that is difficult for the Japanese industries and corporations. They are not very good at promoting themselves. They have difficulty really telling others how good their products are.
Mm-hmm.
And I see it also as a barrier because it's not hardware, right? It's basically they have all the products, let's say, in other industries as well. They have good
Mm-hmm.
products, they have durable products, high quality products, and everything. But they still cannot say to the world, look at us, we have this great product here, so why don't you use it? And
And,
once
and
again, my theory is that it is a cultural trait. The Japanese humility and modesty, everything here plays into this or inability, let's say, to promote yourself. But what is your point of view
well,
on?
my thought on this is that you're absolutely right, and I think that this is one of the contributing factors to another phenomenon that is actually very related, which is the so-called Galapagos syndrome.
Mm,
That basically starting in the late '90s, Japanese technology started branching off from the rest of the world in consumer electronics primarily, um, and the rest of the world did not follow.
right,
And Japan became this archipelago of fantastic technology that nobody else used.
right,
When the iPhone was first introduced in Japan, it was not the huge success that it was other places because it wasn't as much of a leap in performance versus the feature phones that were already for sale in
mm,
Japan.
yeah,
Americans and Europeans, it was a huge leap that you could do all of the things that the original iPhones could do. Um, but from the standpoint of the Japanese, touch to pay, well, you already had that.
yeah,
All of video, you had a digital TV receiver inside your phone, which actually proved to be an important lifeline on the 3/11/11 disasters because people could watch the TV on their phones. They couldn't get into the phone networks because they were all overloaded, but they could still turn it on and use it as a digital television receiver. You don't have that capability built into phones outside of Japan, and I don't know if one seg is still in phones in Japan or not. I hope it is because it was really a lifesaver
yeah,
at that time. No other country has implemented the one seg technology. There was talk about putting it in Brazil, but I don't think that ever went anywhere.
right.
Um, Japan is great at building fantastic solutions that solve so many problems and do it in such an efficient way. And you're right, they're not good marketers,
Yeah,
particularly on the global scale. They're really good talking to the domestic audience.
very good. They excel at that. Yes.
Densu and Hakuhodo, they've got
Yeah.
that on lock.
Yes, absolutely so. I so much agree with you. Yes.
But talking to people outside of Japan, there's a whole level of lack of knowledge that people have. In Japan, when you say I'm such and such, people are like, oh yeah, okay, I know that brand. That brand has been around forever. This is important. I understand what they're talking about. Um, in when you're outside of Japan, there was a brief period of time where Japanese products were perceived of as being higher quality than everybody else. That's mostly gone. I've written about that many times. One of my favorite quotes from, I think it was the third movie in the Back to the Future series, is that Marty and Doc, spoiler
Mm-hmm.
alert, for a movie that's like over 30 years old.
Okay.
But they're looking at the time machine, and this is 1955 Doc looking at the time machine, and he says, well, here's the problem. It's I was looking at the parts, it says made in Japan. And Marty says, what are you talking about, Doc? All the best stuff is made in Japan, because in 1985, that was the perception, was that everything was great. Sony was fantastic.
Mm.
Panasonic was fantastic. Everybody knew those brands, and people lined up the way that they line up now for Apple. Um, that brand equity does not really exist anymore,
Right.
for a whole variety of reasons, which we can talk about another day.
Yes, we should. Absolutely. I cannot wait actually for that conversation to happen. So,
Okay. Okay.
yes. Well,
I think we're over on time, or
yes, we are already 5 minutes over the time,
sorry
and
about that.
I usually, yes, yes. So please keep that thought. Let's continue this conversation. And yes,
Absolutely.
because there is so much more to talk about, and I'm sure that it will be interesting and informative for everybody watching us, of course. But thank you so very much for making time for being on the podcast today, James. I so much appreciate it.
It's
And
my pleasure, and I appreciate everybody who made the time to join us live, and also the people who watch us on replay later. So,
yes, there will be some because I already got a couple of messages saying that I watched the replay. I have to go now. So, to
mhm.
everybody who stayed with us, thank you so very much. And please, if you haven't connected with James yet, you can do that on LinkedIn. James, I don't know whether I'm allowed to disclose your visit to Japan. Is it okay?
Sure.
Yes. So James is visiting Japan later this spring, right? It's basically in
It's
spring, in March,
in March, correct?
if I'm not mistaken. Yes. And I don't know whether you have any time to meet people here because you're going to be here with your students.
Correct.
But yes, but everybody who wants to connect with James, connect with him and talk with him and see whether you can meet him when he's in Japan or when you can meet him when you are in the United States. All right.
Absolutely. I look forward
Yes.
to it.
Yeah, thank you so very much again. And again, have a great Wednesday for everybody who is in Japan. And to you, James, have a great evening, a good night. And well, I hope that your remainder of the week will be productive, as it always is, it seems. And
I
yes,
try. Yes,
thank
and
you.
same to you as well. Thank you very much for inviting me, and I'm very honored to have been able to grace your podcast. So,
I'm looking forward to the next episode with you.
as am I. So,
Thank you.
お疲れ様